Hi guys, it's Rafi here and I'm happy to have you in another video. In the previous video up here, we learned how we can deploy the Prometheus inside a Kubernetes cluster, and we configured it in a way that it can connect to the Kubernetes components and start collecting the metrics related to Kubernetes. And in this video, we want to show how we can visualize all the collected data from the Kubernetes components in a way that we can understand what is happening under the hood, what is happening in the Kubernetes cluster. For that purpose, we are going to use Grafana tool. And what is Grafana? Grafana is an open source platform for data visualization, analysis, and monitoring. And that simply means it can connect to different kinds of data sources and create a graph based on the collected data on those data sources. It's quite popular. Why? Because in one word, working with it is a pleasant experience. Talking about my personal experiences, I would say I have experience working with 3 different monitoring stacks: Datadog, Kubernetes, Elk stack, and Grafana and Prometheus. And Grafana was much more pleasant comparing with the other tools. And also, the other benefit is Grafana is free. So you can have a huge benefits come with this tool for free. So without any further advertisements, let's get into the code and see how we can deploy Grafana into Kubernetes cluster. Okay, just as our normal routine, let's see what do we have in the Git repository right now. We have a directory for tools. Inside tools, we have CI/CD, Argo CD, and Jenkins. And then for monitoring, the only tool that is being deployed inside our cluster is Prometheus. So what we're gonna do now is create a separated directory for hosting the Grafana deployment file and then apply it. Let's see. Grafana. Having the directory structure, let's jump into the Grafana deployment code. Okay, this is a basic deployment file for Grafana inside our Kubernetes cluster. Let's go through it. The first step is defining the namespace. As you can remember in previous videos, all the tools that we are going inside our DevOps lifecycle is hosted in DevOps-tools namespace. So this actually applies for Grafana. And then we need a persistent volume claim. Why? It's quite obvious, because we want the data in Prometheus to be persistent. Again, it's only a test environment, so I just defined 1 GB. Of course, in production systems, you have to decide based on your own scale and adjust the volume size. And then for the deployment itself, there is nothing special, to be honest. We are going to use the latest version of Grafana, and then the default port for Grafana is 3000. So we keep it as it is, and then define some requests and limits for allocated resources, and then attach the PVC we just created to the Grafana. For the service, we have a simple service here with the type of cluster IP. This number is not correct. It should be 3000. And then it's connected to the port 3000 of the target, which is this deployment. And we defined a simple ingress here that is responsible to route all the requests for this host to the service, and port number would be 3000 here. And yeah, that's quite easy, that's quite simple. Of course, in the advanced example of deployment of Grafana, we can have a config map. Inside the config map, we have to define all the configuration related to Grafana. But for time being, we are good with the default configuration, right? We will cover all those topics in next videos, but for time being, let's continue with this simple configuration and the default configurations there. So now let's change our namespace to DevOps tools. And then see what do we have here. The only thing we have is Jenkins. We're good. Now let's change our namespace to DevOps tools. Okay, and then apply the created deployment file. What was that? Monitoring, and then Grafana. This namespace. So let's see, what do we have? Oops, sorry. Okay, looks good. Let's see, what do we have? And then, okay, it's up and running. So I should be able to access to Grafana using this host. Let's go to the browser, and then there you go. Okay, this is a Grafana login page. If this is the first time that you want to log into Grafana and actually you are initializing the Grafana, the username and password both would be set as admin. And in the first attempt to log in, it asks you to change your password. So assign the password for yourself and then log into the Grafana. This is a Grafana environment. After first login, as you can see, going here to dashboards, we don't have any predefined dashboards here. Basically, the sequence should be like this. First, you have to integrate the Grafana to some, let's say, data source, right? So, for example, in our case, we want Grafana to be connected to the Prometheus and start visualizing the data stored inside Prometheus. So the first step always is connecting the Grafana to the data source. For doing so, we can go to the settings here and then go to the data source menu. Inside the data source menu, click on the add data source. As you can see, there are so many different data sources that you can connect Grafana to, but for time being, the one that we want to continue with is Prometheus. When you click on the Prometheus, it's super simple to configure. It needs a URL that Prometheus is accessible through, right? So think about the architecture we have. We have the Prometheus inside our cluster, and Grafana also is inside our cluster. We did not expose Prometheus to the outside world, right? And because of that, we can simply provide the service address attached to the Prometheus in this section. Let's see. Let's go back to the terminal quickly and see what services do we have here. Okay, the Prometheus service name is exactly Prometheus-service. So I am going to use this. Let's go back to the Grafana and then here import 9090. And the reason that I can use the shortened form of this service, not including svc.cluster.local, etc., etc., is only because of the fact that Grafana and Prometheus are both inside the same namespace. If you are about to just deploy them in two different namespaces, that you have to provide the full address for the service attached to Prometheus. But for time being, I think it should work. You don't need to set any other thing here, just save and test. Okay, I mistakenly add extra space here. So save and test, and if the connection with the data source is successful, you should see data source is working, right? And it detects the type and everything looks good. So let's go back to the dashboard section. Now what we desire to have is a dashboard that reveals all the parameters inside Kubernetes cluster, right? One of the benefits of working with Grafana is that whenever you want to achieve a specific dashboard, you don't need to create it from the scratch, because there are so many available predefined, or let's say pre-created dashboards out there in the Grafana Dashboards page. We will see it shortly, that you can only download them and start adjusting them to your own cluster. Having that said, let's search for a dashboard, for a proper dashboard for Kubernetes environment. Going back to browser here and then search Kubernetes Grafana Dashboard. Okay, in the Grafana's website, you can go through all the dashboards. I will search for Kubernetes here. As you can see, there are so many different dashboards available for Kubernetes. The one that we want to continue with is Kubernetes cluster monitoring via Prometheus. So going there, the only thing that you have to do is copy ID to clipboard. Actually, you have two approaches to import specific dashboards into Grafana. One of them is just, if it is already available in the Grafana Dashboards website, then you can simply just copy the ID. If not, you can download the JSON file here and then import it into the Grafana. So for time being, I just copy the ID, going back to Grafana, and then in the dashboard section, you have an import menu. Inside the import menu, you have two options. As I said, you can import the JSON file or just simply provide the ID here and then hit load and boom. That was all. Actually, it detected the dashboards, right? And then it asks you which data source do you want to connect to, right? Just think about it. We have a Prometheus data source. We have a Prometheus which hosts all the metrics collected by the Prometheus from the Kubernetes. So Prometheus data source is the one that we should go with. But in more advanced example, you would have so many different, let's say several different data sources, and then you can choose which data source do you want this dashboard to be connected to. So I will set Prometheus and import. And there you go. This is a dashboard. There is one specific reason that I choose this specific dashboard, and that is the dashboard is completed, but it's old. So it's not that much compatible with new version of Kubernetes. And it provides us the opportunity to fix the dashboards with no data here. As you can see, for example, the pod CPU usage or the pod memory usage or some other graphs comes with no data, right? We want to fix this. Through this, you will learn how Grafana is actually working, how these charts are getting the data, and how we can just fine-tune it or change it in a way that we need it, right? Let's initiate the debugging process, going to the actually this configuration by hitting click here and then go to edit. You can see the query which is responsible to create this chart for us here, right? So there is a query for container CPU usage seconds total, and then there are some parameters, right? And then it should be grouped by a parameter, namely pod underline name. And it couldn't find any data with this specific query we provided. So what could be the reason, right? The first step is first, I would say, let's copy this, going back to Prometheus and paste it here, right? If this is a real parameter stored in the Prometheus, then Prometheus will provide all the data stored about this metric, right? Let's hit enter. And there you go. These are all the data available here. So this parameter is actually correct parameter. So what would be the problem? Maybe some of these parameters are not correct, right? So let's see what's happening here actually. I would just compare one of these results here. I know it's a little bit small, so I increase the font size. Let's say just consider this one here and check all the metrics, all the parameters here with what we defined here. So I would say, do we have image? I will copy it, save it here. Yes, we have image. So image is a correct parameter here. Let's say, do we have name? And then, of course, we have, let's say, host name, namespace, and name. Yes, we have name. But there is a discrepancies here, and it is, we have name, but no name is actually starting with K8s. I think this is some configuration related to older version of Kubernetes, and that is not applicable to our case. So I would just simply delete this line, and then boom, we have some data, right? We have a warning here, by the way. We should consider all the warnings, but first, what I expect to see is have CPU utilization per pods, right? But the only thing that I am saying right now is a simple graph, and that's not what is desired. What would be the problem? Let's check this parameter. Do we have a pod underline name parameter here? Nope, we don't have it. That's the problem. So we instruct Grafana to group all the metrics based on the pod underline name, but there is no pod underline name. So that's the reason we see wrong results, let's say. Let's see what do we have instead of pod name. Going through this, yeah, we have pod, not pod underline name. So let's change it to pod, right? Oh, perfect. Actually, it has auto completion as well. Yeah, very good. So just writing pod and it will completed, and then yeah, there you go. This is a pod utilization, pod CPU utilization per pod. As you can see, there are different pods here: etcd, Kalinko, and Jenkins. One of our deployments, Argo CD, and yeah, I think we fixed it already. We also need to correct the legend here because we don't have pod name, only pod, and then perfect. Let's save it and then go back to the dashboard. Okay, we fixed the first one. I will continue to fix the rest of them, whichever chart that doesn't have data for now, and then let's see what do we have here. So let's look, what do we have? We have a Kubernetes cluster, right? But now we can see all the things happening inside our cluster at a glance. So we can see the network I/O pressure on this Kubernetes cluster, memory utilization, total memory available for this cluster, CPU utilization. We'll cover creating an alert in new alerting system in Grafana in the next videos, but for time being, just consider that you can be notified on high CPU utilization, high network pressure, whatever is happening inside your cluster, and you can easily find what is happening in which pods. Okay, so now we have a graph and dashboards here, and yeah, there are some charts here, but so what, right? You might ask. So let's see how we can actually use it in action to understand what is happening under hood. As you can remember in the videos up here, we created a Jenkins deployment inside this cluster, right? Now the idea is, let's put it on the load. Let's create several parallel jobs together and see what's happening inside this graph and how we can interpret it. Let's go back to Jenkins dashboard. Okay, here is our task that we created for test purposes. Let's go to it and hit build for several times. Okay, as you can see, several tasks initiated in parallel, and this is acting like it will bring up some pods as agents. Definitely those pods are going to use some CPU utilization. There is a download, an upload, and what we expect to see is to track all these behaviors inside the Grafana Kubernetes dashboards we just created, right? Now this job is started working. Let's go back to Kubernetes dashboards. Yeah, there you see. There is a network pressure. As you can see, something is happening in the system. We had a jump in the memory utilization here. And then, as you can see, there are some pods here, recently created pods, JNLP. And as you can remember, these JNLP pods are the agent pods, which are responsible to do stuff and create our jobs. Yeah, there's a CPU utilization here. For the pod utilization, Jenkins started to use more memory, as you can see, something like 600 megabytes for time being. There is a pod network IO, as you can see. We can see which pod is using actually more network bandwidth. And if we go here, yeah. So you see, when something is happening inside the cluster, as you can see here, we start tracking all the changes in our Kubernetes cluster. This is what is really happening under hood. That was the whole idea. Okay guys, it was all for this session. Actually, it was quite a quick session, let's say. We just wanted to see how we can access different data sources in Grafana, how we can create or edit any dashboard and adjust it in a way that it would be compatible with our cluster or infrastructure. And at the end, we reached to a full functional dashboard that is showing exactly what is happening inside the Kubernetes cluster for time being. If you like this video, please don't forget to like the video, do subscribe and share the links with your friends or colleagues. We are in the beginning of the path we started like months ago, so there are so many different topics to be covered. We started with, let's say, elementary ones. Your like and subscription means a lot to me and motivates me to move forward. Bye for now and see you in the next videos.